Okay, welcome. Today's 9.06 L'Hopital's rule. Okay, we're going to go back to limits for a quick second. So we're going to take the limit as x approaches 0 of this function. Now I know that you'll see that we have the exponential function here, and that causes us some anxiety, but it's really going to work out really nicely. So we're going to evaluate this limit above using the methods that we know. So we know that we could just basically plug in 0 to evaluate. And when we plug in 0, we'll get the following. Now we shouldn't worry because the e is here. Anything to the 0 power, just remember that anything to the 0 power is just going to be one whole. So the following would be just 1 minus 1, and 0 squared is 0, and then 0 plus 0 on the bottom, which would give us 0 over 0. Now this is not equal 0, and we have to remember what this means. If you remember, this actually usually tells us that we are going to have some kind of hole, and that we are going to have a hole at 0, or that something is happening there. So what did we do? Well, usually, okay, and remember that stands for RD, removable discontinuity. So what do we do when we encounter this? Normally we look to factor, and we look to cancel something out of the numerator and denominator. Why won't this work though? Well, why won't this work in this situation? We can't really factor something with that e to the x power. All right, so we have to use a different strategy. And that is where L'Hopital's rule comes in handy. So let's move and see what would happen if we used L'Hopital's rule. So we're going to go back to the same equation, and we're still going to evaluate the limit as x approaches 0. But what L'Hopital's rule tells us is that if we can't do that, if we get something like 0 over 0, which is what we got here, then we have an alternate method, which would be to take the derivative of the top and take the derivative of the bottom separately and evaluate those as they go to 0. Notice how this isn't quotient rule. I'm not taking the derivative of the entire function. I'm actually taking the derivative of the top and bottom separately because we're talking about a limit. Also notice that we can only use L'Hopital's rule when we get something like 0 over 0. If it was a 0 on top, it would just be 0. If it was a 0 on bottom, then we'd have to use the sign test with vertical asymptotes. But 0 over 0 is a whole, and we have to use a different sort of factoring. L'Hopital's rule comes into play. So let's use it to finish off this problem. So here, what we have to do is take the derivative of the top and take the derivative of the bottom. Now, some of us might be kind of frightened again by this e to the x power. So let me go off to the side and just remind us what the derivative of e to the x is. And I've done that work off to the side over here. Remembering this formula, when we have e to the u power, to find y prime, we keep e to the u and we multiply it by u prime, or the exponent's derivative. So the derivative of y equals e to the x is going to be e to the x times 1, that 1 coming from the derivative of x. Okay, so now that we have that and we've reminded ourselves, if you don't remember that and that looks very strange to you, you should go back to 9.03 when we did that in notes. Anyways, we're going to continue to rewrite this as the following. Limit as x approaches 0. And now we're going to actually rewrite what the derivatives are. So we now know that e to the x power is e to the x times 1, or just e to the x. Well, what's the derivative of negative 1? Well, that's just going to be minus 0. Okay, now we have to take the derivative of the bottom. So the derivative of the bottom is going to be 2x. The derivative of x is going to be plus 1. Now that we've used L'Hopital's rule to take the derivative of the top and bottom, now we're going to try to reevaluate with a 0 in for all of our x's. And once again, we shouldn't be scared by this exponential function, because remember, if we ever have an exponent of 0, that's going to turn our entire thing into one whole. So that whole thing becomes 1 minus 0. 2 times 0 is 0, over 1 is 1. So 1 over 1 is just 1. Here's our answer. So let's reflect on what we did and why we did it. We used L'Hopital's rule because we started with an initial function where when we plugged in 0 to evaluate that limit, we got 0 over 0. Our normal way of factoring out did not work, so we have to use this other method. L'Hopital states that if you take the derivative of the top and bottom, then we can plug in 0 to find the rest. This would work with a lot of those other things that we've done in the past, We just didn't know how to take the derivative then, and now we do. Take a moment, make sure this is copied in your notes, and I'm moving on. Okay, so if you wanted to summarize what it is mathematically, it would be the following. If we take the limit as x approaches some value of f of x over g of x, two different functions, and we get 0 over 0, then we can use L'Hopital's rules, which states, okay, we're going to take the limit to the same thing, but this time we're going to have the derivatives of the top and bottom function. So in today's check for understanding, you're going to have to answer two questions very similar to these. Why didn't we use the quotient rule? Okay, the quotient rule is normally when we have u over v, kind of like up here, and then we'd have to use that whole box method right up to the side. Well, why didn't we do that this time? What was different about this problem? And I'm going to highlight something right here that is different. And when are we allowed to use L'Hopital's rule? Okay, we are allowed to use it really in one scenario. Okay, so now let's just kind of describe that function. It looks like this, and this was our answer. So it's really important that we can only use L'Hopital's rule with limits, okay? And when we get an answer for that limit of 0 over 0. Okay, so what I'm looking for is you to put that in your own words. So something along the lines of we would use L'Hopital's rule when evaluating limits, and our answer when evaluating would be 0 over 0. So we can use L'Hopital's rule to take the derivative of the numerator and the denominator and reevaluate our function. So now we're going to see if we can use the same strategy to find the limit of this new function. Before we even use L'Hopital's rule, what we have to do is we have to see if we get 0 over 0 first. So I'm going to take a moment to actually write this out. Okay, so we have to take the limit as this function approaches 0. So now we're just going to plug in 0. And I know that some of us might be freaked out because now we have a sine and an exponential function. Let's just take a moment to remember on our unit circle what sine of 0 is. Okay, so 0 degrees is right here. So we're going to be taking the sine of that value. So there's our unit circle. The point on that unit circle is 1, 0 at 0 degrees. And the 1 is talking about cosine and the 0 is talking about sine. So the sine of 0 degrees is 0. So now we're going to write that, and we should also be remembering that e to the 0 is 1. So let's rewrite. So I got 0 plus 0, remembering the sine of 0 is 0. E to the 0 is 1. So if we do this out, we get 0 over 1 plus 0 is 1 minus 1 is 0. Okay, great. Well, actually not great. If there was anything else, we would have an answer. But since it's 0 over 0, we would either look to factor or use L'Hopital's rule. Do I feel comfortable trying to factor this and cancel out? No. But I am comfortable using L'Hopital's rule because we've been practicing the derivative so much. So let's go down and let's rewrite our first step. Now I want you to notice my work organization. I started by rewriting my original function, and I said that that is equal to, this is showing that I'm stating the L'Hopital's rule, this is equal to the limit as we approach the same thing of the derivative of the top and bottom. So I took a moment to just state the rule before I jumped into it, stating that the original is equal to the derivative of the top and bottom when we evaluate a limit. Now I'm again going to rewrite, but before I plug in 0, I have to take the derivative of the top and bottom, remembering that that's what that stands for, and that's the key move in L'Hopital's rule. So when I do this, let's figure out what is the derivative of x. Well, that's just x to the first, so that would be 1x to the 0, or just 1. What's the derivative of sine x? That's cosine x. So we turn this into 1 plus cosine x. The denominator, let's see, the derivative of 1 is 0. The derivative of 4x is 4. Remember, that's going to be 4x to the first, so that's really 4x to the 0, so it's just 4. And then negative e to the x power. Okay, so now we have to remember, okay, how do I find the derivative of e? I'm going to go off to the side and do that again. Okay, when I find the derivative of an exponential function, I just rewrite the exponential function, and then I take the derivative of that exponent, I put it together. So in this case, okay, my exponent was x. Okay, I took the derivative to get 1. E to the x times 1 is just going to be e to the x. So that's going to be minus e to the x. I could put e to the x times 1. But that really just came from my derivative. Okay, that was a big move. And I'm going to kind of underline both of these moves. One where I showed that I was taking the derivative of the top and bottom, and one where I actually found the derivative of the top and bottom. Now I can go on to my last step of actually plugging in 0 to see what I get. I ran out of room to the right, so I'm going to go down below, and I'm going to plug in 0 for all of my x's. And I know that we might be a little freaked out because we have cosine of 0 again, but we already did the math up here. It's on this unit circle still. We've done the we have 0 degrees, cosine and sine, so cosine is going to be 1. So already I can see on the top, I'm not going to have a 0, so this is going to give me my answer. So I have a 1 plus 1 on top, and on the bottom, I'm going to get 0 plus 4, so just 4, minus, oh man, what is e to the 0 again? Well, that's just 1. We talked about how anything to the 0 power is 1. So that's going to give us 2 over 3, and that's our answer. So notice how we're not really finding slope anymore. We're not doing any of that stuff. We're still just evaluating limits, but we're using the derivative to do so. So L'Hopital's rule states, once again, that if you get 0 over 0, called the indeterminate form, then what you are allowed to do is use L'Hopital's rule to find the derivative of the top and bottom, and then reevaluate your function to find your answer. Other quick notes that I want you to make that I'm looking for in your work today. If you're evaluating sine and cosine, then I'd be looking for a unit circle somewhere. If you have an exponential or a logarithmic function, I'd be looking for something like this. Okay, some work off to the side and some annotations that allow me to make sense of this problem when it gets very complicated. See you in Zoom. Happy Monday.